this is what I'm intending to talk about today. Beginning with a bit of an introduction to RAC and DataGuard. We asked you if you can let us know in the chat how familiar you are with RAC and DataGuard. That will may help us pitch some of the content. But because we're aware that some people may not be 100% au fait with these things, we'll have a quick look at RAC and DataGuard very briefly, just to summarize what they can do in terms of fault tolerance and high availability. Then we'll become a bit more specific and talk about service fault tolerance, the concept of a service. Now, all database administrators need to be familiar with what a service actually is. If you're running just a single instance database, no DataGuard, no RAC, no nothing, okay, maybe you can get away with not knowing what services are. But in more complex environments, services and use of services is vital. And in particular, the concept of the database service underpins all of Oracle's high availability capabilities. So we'll talk about service fault tolerance and then move on to session fault tolerance, because fault tolerance has two sides, the server side, the client side. We're talking client server here. Service fault tolerance handles the server side of fault tolerance, session fault tolerance handles the client side. And we'll see how sessions can then survive the failure of a service. And indeed, we'll see how sessions sometimes do not survive the failure of a service. So that first section is the assumed knowledge before we move on to some of the fantastic capabilities of the current release of the database. Transparent Application Failover, TAF, and Transparent Application Continuity, or TAC. So that's our agenda for today. Summary of RAC then. It's a bit difficult to summarize RAC in one slide, a bit ambitious. But in principle, all a RAC is two or more instances opening a shared database. You've got a cluster of two or more nodes connected in various ways, one instance on each of these nodes, and a database on shared storage. That's all a RAC is, two or more instances opening a database on shared storage. For all my demonstrations, by the way, I'm going to be using just a little two-node RAC. What I've got here is, oops. If you look at the environment I have here for my demonstrations, I've got a two-node cluster, a machine called Paris 1, a machine called Paris 2 in a cluster. And on that cluster, I have, among other things, configured a database, oops, SRV CTL status database. And my database is called ORCL, and ORCL is a two instance database with ORCL1 running on Paris 1 node, ORCL2 running on the Paris 2 node. So that's what I'm going to be using, just a little two-node cluster. Now, and we'll see what we'll do throughout most of these demonstrations is crash one of the database instances, and we'll see what happens to the services it's offering and what happens to the sessions against it. The idea of RAC in general, it protects you against instance or node failure. Supposedly zero downtime, well, that's a bit of a qualification, but that's how it's advertised, zero downtime, because in Oracle terms, the database remains open. It remains open throughout. The sessions, your users may not agree with that. Their sessions will be broken. More importantly, perhaps, RAC doesn't actually protect the database. The database itself now becomes a single point of failure. So what does that mean? Well, maybe you've got a cluster in, say, Los Angeles, maybe, and you've got a two-node cluster in Los Angeles, one node fails, everything fails over to the other one, perfect. Well, that won't help you if, say, the San Andreas Fault opens up and swallows all of California. To protect against that, you're going to need DataGuard. Right. So, DataGuard, two or more databases, but only given at any given moment, only one of them is open for DML operation. And this protects you against loss of the database itself. So in my somewhat extreme example, you might have a primary database in Los Angeles, a standby database running in Bogota. Well, in that case, if the San Andreas fault swallows up California, the standby in Bogota can take on all the workload, and that can deliver zero data loss. Does it deliver zero downtime? Not really. The failover from primary to a standby is not going to be instantaneous. Even if it were instantaneous, the sessions against the failed primary will be broken, and there's some quite significant implications for that, and they will then have to be re-established against the standby database, which has then been activated. So previous slide, these are the Oracle's premium products for high availability. RAC theoretically gives you zero downtime, because whatever happens to one instance, the database remains open on a surviving instance. Whereas DataGuard gives you zero data loss, protects you against losing the entire database, or maybe just the storage array perhaps, but it doesn't deliver zero downtime. What you can do, of course, is combine them together. And that gives you what Oracle calls maximum availability architecture, though I think it should actually be called maximum license revenue architecture, perhaps, where you have a primary database, which is RAC, and a standby database, which is RAC. And those two together are Oracle's premium high availability environments.
Yeah, John, I have a question, and I'm just to level set. First, I'd like to say this to the audience, and John may want to expand on it. You know, there's some of you that don't have a lot of experience with RAC, you know, and I'd like to say this because it has confused me in the past. RAC is a high availability or fault tolerance option. Scalability as well. Fault tolerance and scalability. It is not a performance feature. So just with that said, John, do you want to expand on that at all?
That's a very important point indeed. And if you do go for RAC, you need to be absolutely clear on your reasonings. And I must say, if a client ever says, we want to use RAC because it will improve performance, ooh, my heart drops down into my boots. RAC is not really intended to be a high performance capability. You may just possibly, in a data warehouse environment, perhaps a RAC can help because you can get higher degrees of parallelism. You can splatter a parallel query across multiple nodes, but that is going to need a huge amount of tuning, So that is an important point. RAC is not about performance. It's about high availability, fault tolerance. DataGuard, by contrast, you can actually view that as having some performance benefits. Its primary function is, of course, high availability, zero data loss. But then if you have the licenses and you can use active DataGuard, or you have the ability and the interest to configure, say, logical standbys, DataGuard can actually improve performance, which is an interesting point.
So, John, a question in the queue. Is combining RAC with DataGuard incur more cost?
No, DataGuard is included with Enterprise Edition, and RAC is, of course, licensed. But adding the two together, you've already bought the licenses.
Right. Let's see. I did have another question for me in there. And so in 19C, John, we no longer have RAC for SE2. Oh, you answered that one already. Never mind. Over to you, John.
Okay, thanks. Now, drilling down to a bit more detail. The concept of service fault tolerance. So remember how I tried to describe it. The fault tolerance has two sides. There's a server side and there's the client side. Oracle's service fault tolerance underpins all of the high availability capabilities. A bit more theory here for those of you who may, well, depend to do with RAC. From release 11.2, there are two ways for configuring your RAC. You can have an administrator managed database or a policy managed database. Administrator managed databases have been available, basically they date back to the beginning of RAC. The DBA controls what's going on. The DBA decides where the instances are going to run. The DBA decides where the services are going to run. Policy managed databases are in some ways a huge technical advance in that they're a much more declarative approach. The DBA doesn't say, I want this instance here and this service there. The DBA tells grid infrastructure, the clusterware, how many instances he would like to have, and how many occurrences of the service he would like to have. It's a declarative technique. The DBA tells grid infrastructure what he would like, and grid infrastructure then gets on with it. It's a much more sophisticated approach than administrator managed. For the purposes of our demonstrations today, I'm actually using an administrator managed database. And that is because my experience over many years shows that's almost certainly what most of you are doing. If you have a small cluster, as I have, of only 2 nodes, I've only got 2 nodes here, a small cluster of only 2 nodes, almost certainly you will be using administrator managed. Once you get to 3 nodes, 4 nodes or more, then policy management becomes a much more powerful capability. So what I'm working with is administrator managed. I'm going to tell Oracle where I would like my services to run. They will then be protected and relocated as necessary by grid infrastructure, by the clusterware. So, as an example, I shall create a service. Now, I'm going to be using the standard tools for this. And to create a service, what do? We use the srvccl add service command. The help in the current release is fantastic, I think. And with each release of grid infrastructure, the commands become more and more capability, more and more powerful. But I'm going to use the most basic use possible at the moment. And the command I'm going to use is add service for this database, and the service will have a name. And I'm going to tell it minus preferred and minus available. The preferred is a list of one or more instances where I would like the service to be available to run. The available is a list of one or more instances where grid infrastructure is allowed to run the service if it has to because of a problem. So that's the most basic use. Command would be this, srvccl add service. Give the service a name, serv. Which database is it in? The database ORCL. And I want it to be preferred on that instance, but available on that instance. Just remember my database instance itself is called ORCL, and it's got those 2 instances, 1 on each node. So create the service and start it up. So check the status, and we'll see that the service is running on ORCL1, because I said that's the one I'd like it to be on. In many small clusters, people will in fact run their services on both nodes. Now, I'm deliberately simulating more sophisticated environments where I want to have a subset of services perhaps on one node and a subset of services on the other node, but either node can take over the services from the other node if one were to fail. So the service is actually running on ORCL1, but as a user, I don't need to know that because I connect through the scan. Remember that? The single client access name. So to log on, I can do this. SQL plus system Oracle at Paris cluster scan. That's the scan address, the single client access name. Then I ask for listening on that port and ask for that service, SERV. And when I do that, as a user, I have no idea which instance, which node I'm logged onto. Absolutely no idea. Right. I can find out, of course. Assuming I have appropriate privileges, I can query, select instance name from VDOL instance. And I am, of course, logged on to RCL1 because that's where the service is running, as that says. But the end user doesn't know or care. He just issued that connect string with no idea of where his session was actually going to end up. Now, what if the instance fails. Right, so let's simulate an instance failure. And the way I'll do it is a very crude way indeed. ps-ef grep pmon. So here I am on the Paris 1 node, and there is the pmon process of this instance. I'll just kill it. Kill minus, whoops, spelling mistake. Kill -9, 10636. Boom. Goodbye, ORCL1 is the instance. That instance is history. Now, what has happened to the service? Well, srvctl status service. My service was called serv. Well, knock me down with a feather. It's relocated to ORCL2. And that's the basic service fault tolerance. Something goes wrong, grid infrastructure detects that there's been a problem, and it relocates the service to the surviving instance. Note that in the background, a lot more is going on, and if you were to check the status of the database, for instance, check the status of the database itself, grid infrastructure will have detected that the instance had failed, and it has already restarted it. But that's a different part of the fault tolerance. So what happened then? The instance failed, the service was virtually instantaneously relocated, and then in the background, grid infrastructure restarted the failed instance. But what has happened to my session? If I try to run that query again, oh dear, the session is toast. Right. We need session fault tolerance.
John, I have a question about what you just presented. Apex, we do a lot with Apex. And, are we talking about reestablishing connection pools automatically? How deep does this go? Is the application server going to detect the problem?
Ideally, it would. With Apex in particular, we've got your Apex connection pools. The connection pools logging onto the database instance probably as Apex public user or ORD public user. Those pooled connections will be client server connections. They will have been broken, just as this session was broken here. However, the middle tier software, and the Apex ORDS listener will do this, may well be capable of detecting the problem and re-establishing its session automatically. To simulate that, my session has detected the problem. So what's it going to do? If it's well-written software, like say the Apex ORDS listener, it's going to reconnect. It will issue a connect string. Note the identical connect string, going through the scan, identical connect string, and I've logged back on. What am I logged on to? Well, if we look at the instance name, hey, I've gone to the other instance. Because that, of course, is where the service called SERV was relocated to. So depending on your client software, that may happen automatically. With SQL+, of course, I had to initiate it manually. Apex connection pools should re-establish themselves.
One more from me. So crashed instances and the service. Does the service fall back or fail back to where it is meant to be? I'm not even sure.
It can fail back in the very latest release. In the current, by default, as we've got it here, my service was created as being preferred on ORCL1 and available on ORCL2. So it started up on that instance failed, it was relocated to that instance. And by default, it's going to stay there. So failover is automatic, fail back doesn't happen unless you initiate it manually. However, in the very latest releases, I think from 18 and certainly in 19, you can actually automate the fail back if you wish to. They've added a new facility to when you create your service. There it is, failback. Failback to the preferred instance for administrator managed database. And that's very new indeed. And the default is no, which is all backward compatibility. But in the latest release, if you set that to yes, then when the other instance restarts, which it did automatically note, the service would relocate. A nice little enhancement in the latest release.
So John, I'm looking at, a page full of, on your screen, of options. This scares me a little bit. It looks hard to manage, and I'm also concerned about reliability. Can you tell us anything about that? Say anything to that?
Oops. What I can say is that this is good technology. It is good technology. Yes, it's getting horrifically complicated, but it's good technology, and a lot of it is very mature technology. The concept of service failover dates back to release 10. So we're going back many, many years. Everything we've seen so far is rock solid, reliable technology. And the simple configuration will often be all you need. Yeah, it's good technology and it works.
Okay, a little bit like Microsoft Word. It's got a million options we don't use, but 2 of them. Great. Thanks very much, John. Back to you.
Okay. So the sessions, as I demonstrated, my sessions are broken. As we discussed a moment ago, the middle tier software, your application server, may be able to detect the problem and reconnect automatically. Even if it can do that, though, if there were a call actually in progress, it would fail. My Apex connection pool might be re-established by ords in the background. But if a requests are actually running for a user at that moment, an error will be returned. Furthermore, a transaction, an in-flight transaction. If the session has a transaction going on, that transaction will be lost. It will be rolled back. This is Oracle's architecture. If a transaction doesn't commit, it gets rolled back. So that's 2 major problems. Calls in progress fail, in-flight transactions reversed. It's the same thing, by the way, if you fail over, and I've been talking about and demonstrating failover between instances in a rack. It's the same thing with failover from a DataGuard primary to the standby. It can be automated, but there will be errors if a call is actually in progress. An in-flight transaction will be lost. The DataGuard failover is 0 data loss, but 0 data loss doesn't mean that uncommitted transactions survive. They cannot do so. What we see from this, though, is that service high availability isn't enough. We need session high availability too. The sessions have to follow the service so they don't have to reconnect. And ideally, any work they're doing will continue without the end user noticing at all. And if you can give me a quick break to get my voice back to you, Dave.
Thanks, John. Hey, everyone, I'm concerned that you guys aren't asking enough questions. Had we not specified a prerequisite that we should have? Are you following along with John, or you have questions that you just don't want to ask? But I urge you to ask questions, or tell us, that we should have told you needed to know RAC or DataGuard or whatever. So let me know what you're thinking there. As I said before, John leads up our database administration services. So if you contact us for, a new installation, upgrades, patches, anything you'd like, migrating to Oracle Cloud or migrating to AWS, we could do that for you, relieve you guys of some other, so you're free up to do other things, and of course tuning. So John is really fantastic at tuning. I would like to say the best I've ever seen, but obviously you might not feel that way. You might feel you're the best you've ever seen, or someone else is. But whatever, I think we can help you. Short projects, long projects, it's all good. And of course, Apex developers on our team, headed up by Tyson Juglay, can be very helpful in many sorts of ways. So whether it's training or mentoring or a consulting project, building an application for you, or helping to build, being a team member, we can do all of those things for you. Of course, 90% of what we do now, if not more, is remote. Keep that in mind. With COVID and everything else, it's pretty much the way to go now. One of the services that is very popular is the database health check. This is a review by John looking at how you've got your database configured, and it's a basic health check, gives you a documented report of everything we've looked at and our findings and recommendations for modifications if required or if necessary. We do not do implement the recommendations unless you have asked us to do it. We can go through our recommendations in detail with you in a meeting, and you can decide to have us apply some of the recommendations or all of the recommendations, or decide you want to do it yourself. So the database health check is a popular service, and give us a call or an email if we can help you on any of that stuff. So really, I urge you guys to start asking questions. It always concerns me a little bit when you are not asking questions. So thanks, and John, back over to you. Thank you.
Okay, thank you. Yeah, the health check that Dave mentioned can be quite valuable because, of course, your knowledge of your site, your environment, your application is astronomically superior to any knowledge we would have as outsiders. But on the other hand, having an outside person look at the site from a step back, people often, our clients have found that very valuable in a number of ways. Now, for the second part of our lecture here, we're going to look at implementing transparent application failover, implementing transparent application continuity. Now, transparent application failover, it's been around for a long time. It dates back to release 9. It's been significantly enhanced through the releases. The idea is that if a database instance crashes, the session will survive. And I'm going to build this up slowly. First, the basic usage. Now, to configure it, I've already got my service. And the service I created, remember, srvctl config, the configuration of my service in the database ORCL, and the service was called serv. Right, so that was the configuration of the service, and it will run on primary instances, not standby instances, and there are a few other, but it's default to everything. The only thing I specified was preferred on that instance, but run it on that one if you have to. Why would you have to? Because that one's failed. Now I'm going to make it a bit more sophisticated to configure the basic usage of transparent application failover. So what I shall do is srvctl modify the service. So I'm updating the service definition in the cluster registry of this rack. And the service SRV, I'm adding failover type. Failover type select. Now the options for failover type in the current release, all of these. Failover select is the highest level of fault tolerance you have until you get to release 12. Release 12 introduced transaction. Release 18 introduced auto. So starting with selects, that's the basic usage that the majority of sites will be using. And I'll stop the server, make sure that's, oops, I'm just going to stop the service and restart it, just to make sure the change has come into effect. So what happens now? Well, I'll log on to the service as I did previously. Logging on the system through the scan, requesting that service. And remember, as a user, I have no idea where my session is, but I can find out, and it is against ORCL1. No choice, because that's the only instance where the service is running. Now, I'll make the example a bit more complex. We were talking about Apex earlier. So let's pretend to do what Apex would do, and many other applications. I've set a session identifier to John. That's what Apex does when you pick a connection from the connection pool. It's what eBusiness Suite does. When you log on to eBiz, you set an identifier so that the database knows your application ID, not just your schema logon. So the database now knows who I am. For example, there I am, using a syscontext call. And just to make it a bit more complex, I'm going to configure my session to go to Germany. Right, my session has been changed. As we can see here, my session is now saying that it is no longer Wednesday, it is Mittwoch. So I've logged on and I've done some work, including configuring my session. What now happens when we crash the instance? Okay, well, there's my PMON process, kill -9, 1566, 1566. Okay, that's crashed the instance, and the service, check its status, has relocated to ORCL2. What's happened to my session? Select instance name from VDOR instance. Wow, my session has survived. That's pretty cool. Failed over completely transparently. But there's a problem. Who does Oracle think I am? It knew I was John before. Oh dear. The database has forgotten who I am. Check the date. Ah, I've moved back to England. So this level of fault tolerance is very good. The session survives transparently connected, but all the session state information has been lost. So that's all we had until very, very recently. So what do we have in the current release? We can take things a step further. Now, what I'm going to do now is take it to another level. So from release 12.2, there's a new option that I would say all sites should enable. And it's this: SRV CTL modify service, SERV, failover restore level 1. A new option, failover restore, didn't exist until very recently. And once again, I'll just stop the service and restart it. With that new setting in there, what happens now? Right. Well, I log on as normal, connect to the service, and of course, I'm on ORCL1. I'll set my identifier that was lost before. Remember, if your identifier is lost, well, that means that your application simply isn't safe to run in this environment, if it's relying on that. So there I am as John, and I'll even go to Germany, as I did previously.
John, when you're ready for a couple of questions, we got some stacked in the queue.
Please do.
Okay.
Oh, hang, no, give me a couple of minutes. One moment, and I'll
No
just
worries.
finish off this now. And then that'll be a good spot. Okay, kill -9. Let's see. I hope you appreciate how brave it is to do live demos like this. But let's kill the instance again, because my session, the service should have failed over, and it has. My session 2 has failed over, but has it remembered this? What's my client identifier? Hey, it still knows who I am. Does it remember as I move to Germany? Yes, it does. This is a huge technical advance. And quite simply, all RACs should implement that. Dave.
Yeah, thanks, John. So I guess in general, these features and capabilities work when your environment is Java on Tomcat. Or Java.
This is a declarative technique that I've been demonstrating. It doesn't really matter what your client environment is, as long as it is an OCI aware application. So what do I mean by OCI? Well, obviously, if it's written in C linking in the OCI libraries, then it's going to work no problem at all, as with SQL+, for instance. If it's a Java application, well, then it depends on how well written the Java application is. If it's using the JDBC thick client, for instance, the JDBC thick client includes your OCI libraries, so it's going to work. If it's using a JDBC thin client, then you're going to have problems. And you need to think about the environment you're running your software in. If it's using Oracle's Universal Connection Pool, Oracle includes the technology. If you're using WebLogic, Oracle includes the technology. If you're using Apex and ORDS, ORDS, of course, includes the appropriate technology. So to do all this, you need to be, in a sense, an Oracle-aware client.
Brilliant. So I like this one to enable transparent application failover. Is there any configuration on the client side or the application side?
Absolutely none. That's why I love it so much. It's a declarative technique. I do it as the DBA, and the developers don't even have to know it's happening.
So I think this is a question really more about, comparing basic RAC to what we're speaking about today. And I'll read it out to you. Even if you do not have a service added to RAC, doesn't RAC still take care of failover to a surviving instance and having the business continue?
If you want any sort of automation, you have to go through services. You have to. Without use of services, the database remains open, but what's happened to your sessions? Now, the use of services underpins all of the high availability capabilities. Just because the database stays open, that's no good if your clients aren't automatically reconnecting.
Yeah, there used to be something called FAN, right?
Fast application notification.
Where FAN went.
Fast application notification, or FAN, is really an alternative to TAF. You would configure transparent application failover, or you would configure fast application notification. Fast application notification is in fact the underlying technology for transparent application, transparent application continuity, which is our next topic.
Brilliant. Okay, I'm going to move a little quick here because we got lots of questions coming in. I thank you guys so much for them. This switch is because of RAC. Is it possible with only a data guard implementation?
A lot of it is. Transparent application failover will certainly work from primary to standby. The only issue you have to think about is configuring because of time lags. If you look at when you configure your service, here we are, adding your service, you can configure delays. We have the failover delay, failover retry. Within a RAC, failover from one instance to another should be sub-second. If it's a failover from a primary in Los Angeles to a standby in Bogota, the failover ain't going to happen in a couple of seconds. It's going to take a few minutes. So you need to configure the service so that it's prepared to survive a longer period for the switch over, the failover to succeed. But yes, it will certainly work, nothing to do with RAC, it will work with DataGuard as well.
Okay, great. So the failover restore capability only works with RAC and not an active DataGuard situation?
I find it hard to imagine how it could function with DataGuard. You've got the timings to consider. It might well work, but you need to think of the effect on the client. If the failover to a DataGuard standby is going to take several minutes, what's the effect on the client going to be? Will the browser have timed out? There are too many other things going on that might cause a problem. With a RAC, it's sub-second. But if you're failing over from primary to standby, there are other things in play there that might fail. Things might fail for other reasons.
Brilliant.
Even if it's only just timeouts.
All right. Let me give you one more. Are there any configuration requirements for the listener, SQLnet, or TNS names? TNS names would be on the client side, so I don't think so, but what about listener and SQLnet?
You rely on the SCAN, the single client access name. All your listeners should be configured as part of grid infrastructure, and the wizards should take care of that.
Brilliant. Thank you, John. Thank you so much.
Let's take this one a step further. We've got just about enough time. What I've demonstrated, I hope, is pretty powerful, but it still isn't good enough. Imagine the situation where I'm in the middle of a transaction. Right. What if I do this? So here I am logged on and just query the table. And there's Scott.emp, Mr. Smith, and there he is. Then I do some DML. I delete Mr. Smith. One row has been deleted. Where is my session? It's on ORCL2 because it failed over. So go to ORCL2 and crash that instance. So I'll kill my PMON process, that process there. Right. Well, it failed over before, didn't it? But what's happened now? Oh dear. End of file on communication channel. TAF cannot fail over a transaction. If your session detects an error and you're in the middle of a transaction, your session is gone. So what do? Well, you can reconnect, of course. I can reconnect, and that will have got me, oops, failover hasn't completed yet. Just check the status. That is running on ORCL1. Back off here and reconnect. I can reconnect, and my session will have been re-established against ORCL1. But what's happened to my transaction? Well, I deleted Mr. Smith. Well, what we'll see is that, oops, I deleted Smith, and after the reconnection, the transaction's been rolled back. So TAF isn't good enough. That's when we move to transparent application continuity. Now, transparent application continuity, TAC, it's actually been around since release, application continuity. Application continuity is introduced in release 12.1. but it required the client to do all the work. It had to be a Java client, and this is all part of JDBC standards, but the Java client had to be informed of the problem and take appropriate action. So application continuity 12.1, the client had to be aware of what was going on. It had to be implemented by the developers. And that did allow, however, transactions to appear to fail over. What they've done in the latest release is introduce transparent as a key word in front of application continuity. This is a fantastic capability. It allows me as DBA to use a declarative technique that allows transactions to fail over. So this is very new, but let's do it. I'm going to modify my service in a couple more ways. Modify my service SERV to add failover type auto. That's the new capability. The earlier ones, we had failover type select. Transaction was application continuity, but the developers had to do it. In the latest release, we've got auto, and that is transparent application continuity. There are a couple of other things, notification true. I mentioned FAN, fast application notification. This allows my service to subscribe to the messages that fast application notification transmits. Commit outcome, true. That's a facility that allows the client to detect whether a commit succeeded or not. But it's all completely declarative. So just by doing that, I have enabled transparent application continuity. I'll bounce the environment, bounce the service, stop the service, and restart it. And now we'll see the effects and then return to the slide. But the idea is we should see a transaction failing over. So I'll connect. Oops. Let me log on again. I will, of course, be on instance ORCL1 at this point, the preferred instance. If we look at the Mr. Smith, he's there because he was rolled back, or his deletion was rolled back. And then we'll get rid of him again. Goodbye, Smith. So no row selected. Then we simulate a problem. Kill the instance. Goodbye, instance ORCL1. Let's check the service. We see as before. Check the status of the service. And the service has relocated. What's happened to my session? Well, the session has been relocated. What about my transaction? I had an in-flight transaction. So notice already my session has survived, whereas previously the fact it was in a DML transaction meant it failed. And that's fantastic. The transaction itself has been failed over. The transaction's failed over. What happened is during the crash, that transaction was rolled back. It was rolled back. But there's a replay going on in the background. That means the uncommitted work is repeated after the failover occurs. So as far as the client is concerned, nothing happened at all. And at this point, I can do what I like. I can continue the transaction, get rid of another person. I can commit the transaction. So the client, this is perfect fault tolerance. It works for OCI, it works for .NET, it works for JDBC, Universal Connection Pool applications, JDBC thick clients, of course, or if you've got thin client stuff, UCP applications will work as well. And the beauty of it is declarative technique, no developer input whatsoever. It's, in my opinion, almost magical. And quite simply, all environments should consider enabling it.
John, let me throw a couple more questions at you. So we've got, let's say, a policy managed RAC. Do we still need to have services added?
Absolutely. You've got to be using services. Services enable all of these capabilities.
Brilliant. Okay, so if the service is not configured initially and only the database name is used as the service, can the new service be configured similar to database name to avoid so many changes at the app side?
I think it would be easier to change the database name. Oracle has been saying for several years you should not be using that default service. You can't configure it. But there should be no change needed within the application. All you'll be doing is changing your TS names entry to request a different service name. The client shouldn't be aware of any difference. So it shouldn't be any trouble.
Okay. TIBCO. I don't think we're going to know the answer to this one. Tools like TIBCO, which will allow the use of a thin client. I guess what you're asking are any options of tools like TIBCO available here. I'm not sure we can go there. John, are you familiar with TIBCO?
No, I'm not. But if it conforms to these, if it's OCI, .NET, JDBC, or running a universal connection pool, then it'll work. And that should be the vast majority of applications should be covered by those.
All right. Back to database name thing, but what about moving back to ORCL1 from ORCL2 in TAC?
The services will bounce to and fro. One could repeatedly kill alternative instances, and the sessions will bounce to and fro as well. As long as there's always one running instance, the sessions will survive.
Right. So back to that TIBCO thing, Abhishek has clarified. So TIBCO uses the thin clients. Can we make this work at all with the thin client?
As long as you bring it into the universal connection pool, yes, but otherwise no. Oh, no, otherwise no. It'll have to be, what you're having to do in that case is you can't use the transparent technique. You'd have to use application continuity, not transparent application continuity. To make it transparent, i.e. I do it as DBA, there has to be a certain amount of Oracle awareness on the client software, which is any of these. If that isn't there, you're going to be using application continuity, and that means your software has to be written to do it. It's all part of the Java standard, but the application has to be written appropriately.